Hello, good morning all. In today's lecture, we are going to see all the activities of your first chapter. So, activity 1. In this, the activity is about magnesium ribbon about 3 to 4 centimeter long. By rubbing it with sandpaper, hold it with pair of tongues, burn it using a spirit lamp or burner, collect the ash so formed in a watch glass as shown in figure, burn the magnesium ribbon keeping it away as far as possible from your eyes. What do you observe? Here it is given that there is magnesium ribbon, it is burned. So when it is burned, burning will be always in the presence of oxygen. So what it will form when it is burned, it will form magnesium oxide, right? And here 2 so this is balance now. Okay, magnesium ribbon will burn with a light and magnesium, and it will burn and it will left out with an ash, and this ash is uh, magnesium oxide. So magnesium oxide, when it is burned, it will form an ash, white ash, and it is formed as magnesium oxide. So this is first activity, and this is the reaction Mg when burnt with oxygen. It will form magnesium oxide. Now activity number 2. Take a lead nitrate solution in a test tube. Lead nitrate PbNO3. Yes, lead nitrate solution. Add potassium iodide. Potassium iodide. Then what do you observe? When lead nitrate reacts with potassium iodide, it will form double displacement reaction. It will form potassium it will form lead nitrate and potassium, lead iodide and potassium nitrate. Sorry. When lead nitrate solution is reacted with potassium iodide, it will form lead iodide and potassium nitrate solution. And here PbNO3 reacts with Ki to form PbI2 plus KNO3 by double displacement reaction. And in this PbI2, it is a yellow precipitate which is insoluble in water. It will, when this reaction will happen in a test tube or somewhat, there will be substance here left out. If we dissolve in water, it will not dissolve in water, it is insoluble in water, yellow color. So yellow precipitate is formed in activity 2. So what you will observe that lead nitrate reacts with potassium iodide to form lead iodide, which is insoluble in water and yellow in color, and potassium nitrate is left. Okay, next. Take a few granules of zinc in a conical flask or a test tube. Add zinc. Activity 3. And zinc granules Zn is taken. Add dilute HCl. HCl dilute is added to this. Do you observe anything happening around the zinc granules? Here displacement reaction will take place, exothermic reaction. So zinc will displace hydrogen and it will form zinc chloride, and hydrogen gas will be released with heat. Exothermic reaction, this is an exothermic reaction, so heat will be released. So when you add this in a test tube, after this reaction, test tube will start heating. bubbles of hydrogens are formed and heat is released. So this is activity 3. When zinc is added with dilute HCl or sulfuric acid, zinc chloride and hydrogen gas will be left over, and hydrogen gas will be released with some heat. Okay, activity 4. Take a small amount of calcium oxide or quicklime, calcium oxide, in a beaker. Slowly add water to this. When reacted with water, it will touch the beaker as shown in figure. Do you feel any change in temperature? It will form calcium hydroxide and heat will be released, because calcium oxide, it reacts vigorously with water, and then it will produce calcium hydroxide, or which is also known as slaked lime. And with this reaction large amount of heat will be released. So here also beaker will or test tube will be heated. So this is, you can see here, it is in combination reaction and it's reacted, and one single product is formed, which is calcium hydroxide or cyclane. Now activity 5. Take a 2 gram of ferrous sulfate crystals in a dry boiling tube. Ferrous sulfate crystal, they are green in color. Take a 2 gram of ferrous sulfate crystal in a dry boiling tube. Not the color of ferrous sulfate crystal, they are green in color. Heat the boiling tube over the flame of a burner. Observe the colors of crystal after heating. When this is heated, it will form sulfuric dioxide, ferric oxide, so this will be the reaction, and then this is heated and this color will change into brownish black color. So when ferrous sulfate crystals are heated, green colored of ferrous sulfate crystals are heated, it changes into brownish black ferric oxide and sulfur dioxide. Smell of burning sulfuric dioxide is, we can smell that, is observed. So this is activity 5. Now activity, take 2 gram of lead nitrate powder, PbNO3. When reacted, hold the boiling tube with a pair of tongs, heat it over a flame. What do you observe? Note down the change. PbNO3, when it is heated, it will form PbO and NO2 and O2. So in this reaction nitrogen oxide gas will be released and lead oxide is left over, and this will be a brown residue, brown colored, and brown fumes are observed. Brown fumes are observed when nitrogen oxide is heated, and little bit smell is also observed in this reaction. So when lead nitrate is boiled, it will form lead oxide, nitrogen gas, and oxygen also will be released. Activity 7. Take a plastic mug. Okay, this is electrolysis. So in this mug there will be a 2 anode and cathode. Now they are dipped in a water and covered it with a test tube, and then this anode and cathode are connected with a battery. which is 6 volt, and they are tightly fixed with a rubber stopper. And suppose this is anode, this is cathode. Okay, so the take a plastic mug, drill 2 holes at the base, fit rubber stopper in this hole, insert carbon electrodes in rubber stopper, connect this electrode to a 6 volt battery, fill the mug with water such that electrodes are immersed, add few drops of dilute sulfuric acid. Sulfuric acid is added, and 2 drops of dilute sulfuric acid. Take 2 test tubes filled with water and invert them over these 2 carbon electrodes. Switch on the electric current and leave the apparatus undisturbed for some time. You will observe formation of bubbles at both the electrode, and these bubbles displace water in the test tubes. In the is the volume of the gas collected the same in both the test tube? Once the test tube are filled with respective gas, remove them carefully, and this gas one by one bring a burning candle close to the mouth of this test tube. So what will happen? We have to observe after this reaction. In one it will form hydrogen, and one it will form oxygen. So gas collected at anode will be oxygen, and gas collected at cathode will be hydrogen. We are asked that anode and cathode are placed with dilute sulfuric acid, and test tube filled with water is placed on them. So after passing an electric current, hydrogen gas and oxygen gas will be liberated in the test tube, and at anode oxygen gas is liberated, and at cathode hydrogen gas is liberated. And when we put an fire near any of the test tube, on one of the gas catches fire and burns with a sound, which is hydrogen gas, and on another gas it will burn very brightly, like, which is oxygen gas, like a candle. So this is the reaction happening, and observations are on fire, sound and fire, hydrogen gas, and it burn brightly will be oxygen gas, and oxygen will be at anode, and cathode hydrogen will be at cathode. So this will be the reaction, and here volume hydrogen will be twice than oxygen. So 1:2 ratio, oxygen is to hydrogen. So 2 hydrogen as compared to 1 oxygen. So now next activity. Take 2 gram of silver chloride in a china dish. What it is color? Place this china dish in sunlight for some time and observe the color of silver chloride after some times. Okay. Silver chloride AgCl is placed in a china dish, and when it is kept under sunlight, it will form Ag plus Cl. In decomposition reaction, this is an example of photolysis process. When silver chlorides turn grey in sunlight because silver metal is formed due to photolysis reaction and chlorine gas is evolved. So this is decomposition reaction, and it is also photolysis reaction of decomposition reaction. So this is an example of. So what you will observe, silver metal is observed, and chlorine gas is evolved. So activity 9 next. Take 3 iron nails and clean them by rubbing with a sandpaper. Take 2 test tube A and B. Tie 2 iron nails with a thread. . Immerse them carefully in a copper sulfate solution in test tube B for 20 minutes and keep one nail aside for comparison. These are dipped in a sulfate solution, copper sulfate solution. After 20 minutes, takes the nail out from the copper sulfate solution. Compare the intensity of blue color of copper sulfate solution and test tube and compare the color of nails dipped in the solution. First, copper sulfate is blue in color. When nails are dipped in it, its blue color changes and it will form a greenish white color, greenish color. So when copper sulfate is dipped in copper iron is dipped in copper sulfate solution, it will form ferric oxide. Sorry, copper metal will be released and formation of iron sulfate. So copper sulfate solution when dipped, iron is dipped in copper sulfate solution, and after 20 minutes there is iron sulfate and copper metal will be released, and this blue color solution will turn green color, greenish color, and in iron nail you can see this is a metal and it is almost like grayish silver, and it will turn into brownish metal. A layer of sulfate is formed on this top of this. So copper sulfate solution is blue when nail is dipped and its blue color changes, and this happens because of displacement reaction. Here this is displaced because the copper is more reactive than iron, and new product iron sulfate is formed and copper is released. And when you compare, uh, in test tube A there is dark blue color and in test tube B there will be a greenish substance is formed, and nails become brownish when it is dipped. So this is all about activity 9. Now let's take activity 10. Activity 10 is take a 3 ml of sodium sulfate. In another test tube, take 3 ml of barium chloride solution and mix the two solutions together, barium chloride. When this will react, it will make double displacement reaction. And it will form barium sulfate and salt NaCl. So barium sulfate is formed and this is white precipitate. So when sodium sulfate reacts with barium chloride, white precipitates of barium sulfate is formed in this reaction and NaCl is also observed. In activity 11, heat a china dish containing 1 gram of copper powder. What do you observe? In a china dish, heat a 1 gram of copper powder. So copper when heated, it will form copper oxide. This is combination reaction. The surface of copper powder on heating, it will become black, and copper when heated with air, it will react with oxygen to produce copper oxide, and that will, and copper oxide is seen as black in color. So we completed all the activities. In homework, write this reaction and the type of reaction. Okay, write all the equation, this reaction of an activity, and send it me. uh, Almost 11 activities we saw, and 11 reactions will be there. So write all this reaction and send it to me. So here now we are at the end of the chapter. We completed in-text textual and all the activities. If you have any doubt, just feel free to call me. Thank you and have a nice day.